When you first stand next to a Komatsu D475A, it's honestly hard to process just how big it is. We're talking about a machine that weighs over 115 tons. To put that in perspective, that's about the same as 25 African elephants or a small fleet of semi-trucks. It's a literal mountain of yellow steel, and its only job in life is to move other mountains. But here's the thing. If you've spent any time on a mine site or around heavy iron, you know that raw weight and brute force aren't actually enough. To be honest, a machine that is just heavy is usually just a very expensive anchor. In the high-stakes world of large-scale mining, you have to be able to take all that mass and actually translate it into productive work. If you can't do that without shredding your tracks, boiling your hydraulic oil, or burning through your entire profit margin in fuel, you've got a problem. Most people look at a dozer this size and they just see a giant shovel on tracks. But if we strip back the paint and look at the engineering underneath, we find 5 distinct layers of technology that work together in this silent, perfectly timed harmony. It isn't just about having a big engine, it's about a sophisticated mechanical and digital ecosystem. Today, I want to break down those 5 layers, from the way the tracks grip jagged rock in an iron ore pit to the digital brain that lets a person operate this beast from an office hundreds of miles away. The first layer, and arguably the most important for the machine's survival, is what I call the grip layer. This starts right where the machine meets the earth, the undercarriage. Now, in a standard bulldozer, the track frame is usually just a rigid, solid beam. On a flat construction site, that's fine. But a mine site is a nightmare for a rigid frame. It's covered in boulders, uneven benches, and abrasive shot rock. On a rigid system, when you hit a bump, the whole machine acts like a seesaw. Parts of the track lift off the ground, you lose surface area, and the tracks start to spin. In mining, track spin is the ultimate enemy. It wastes fuel, but more importantly, it grinds down those expensive undercarriage components in a matter of weeks. Komatsu's fix for this is something they call the K-Bogie oscillating undercarriage. Instead of one solid beam, they've basically given the dozer a high-tech suspension system. The track frame is broken into articulated sections, bogies, that pivot independently. Think of it like walking on a rocky beach in sneakers versus stiff ski boots. The bogies allow the track to wrap around rocks and obstacles. This ensures that the maximum amount of track stays pinned to the ground at all times. By maintaining that constant contact, the machine isn't just more stable, it's significantly more powerful because every ounce of weight is being used for traction. Plus, it saves the main frame from taking those massive shocks when you run over a boulder, which keeps the whole machine from shaking itself to pieces. But having all that grip doesn't mean much if you can't get the power from the engine to the tracks efficiently. That brings us to the second layer, the efficiency layer. Almost every large dozer uses a torque converter. It's a brilliant piece of engineering that uses fluid to multiply torque, which is exactly what you need to get 115 tons of steel moving from a dead stop. But torque converters have a dirty little secret. They are incredibly inefficient. Because they rely on fluid coupling, they generate a massive amount of heat and cause what we call parasitic power loss. You're essentially wasting fuel just to stir up oil. The D475A solves this with an automatic lockup torque converter. Think of this as a hybrid transmission. When the machine is under a heavy, slow load, like when it first bites into a bank of rock, the converter stays in fluid mode to give you that necessary torque boost. But the moment the machine gains some momentum and enters the haul phase of the push, a clutch engages and creates a direct mechanical connection between the engine and the transmission. Suddenly, there's no more fluid slip. Every single bit of horsepower goes straight to the tracks. Field data from mines in Australia and Europe shows that this little transition can cut fuel consumption by about 10%. When you're running a machine that burns hundreds of liters of diesel every shift, that 10% isn't just a number, it's a massive chunk of change saved every single day. Now, once you've got the power and the grip, you need to be able to use it accurately. That's the third layer, the surgical layer. Most people assume a dozer blade is just a blunt instrument, but on a D475A, it's closer to a precision tool. This machine is usually fitted with a dual tilt system.
On a normal dozer, you can tilt the blade left or right to steer, but with dual tilt, you get hydraulic pitch control. This lets the operator change the attack angle of the blade while they're moving. If they hit a section of really hard bedrock, they can pitch the blade forward, the pitch dump, which angles the cutting edge down like a chisel. It forces the blade into the ground and breaks the surface of the rock. Once they have a full load, they can pitch the blade back, cradling the material so they can haul it across the floor without it digging in too deep and bogging down the engine. It turns the machine from a blunt shovel into a precision instrument, allowing the operator to move more tons per hour without overworking the engine. Even with the best blade and suspension, we still have to deal with the human element, which leads us to the fourth layer, the protection layer. We call this track shoe slip control. Let's be real, every operator wants to push the machine to its limit, but in a high abrasion environment like a granite pit, if you spin those tracks for even a few seconds, you're basically putting your track shoes into a giant industrial grinder. It's an incredibly expensive mistake that happens way too often. Komatsu decided to automate the solution. The D475A uses sensors to constantly compare the speed of the drive sprocket with the actual ground speed of the dozer. The moment the computer detects that the tracks are spinning faster than the machine is moving, it steps in. It automatically backs off the engine output and adjusts the pressure just enough to stop the slip. The operator doesn't have to feather the pedal or listen for the engine to labor. The machine handles the finesse, so the operator can focus on the big picture. This is a massive hidden gem because it lowers the cost per hour by making the undercarriage last significantly longer. The final layer is what truly defines a mining beast in 2026, the data layer. In the modern mining world, the most valuable thing isn't actually steel, it's information. The D475A is packed with Comtrax Plus, which is a telematics system that's constantly talking to the fleet managers. It monitors everything from the health of the gears to the temperature of the hydraulics in real time. This allows for what we call predictive maintenance. It's the ability to fix a tiny seal before it becomes a catastrophic final drive failure that shuts down the whole pit.
But it goes even further than that now. With the latest models, we're seeing the full integration of intelligent machine control and even teleoperation. We've reached a point where these 115-ton beasts can be operated remotely. This takes the human being out of the hazardous dust zones and away from unstable high-wall edges, letting them operate the machine from a climate-controlled station far away. It's the ultimate combination, the massive physical power of the D475A paired with the safety and precision of a modern tech company. When you put all 5 of those layers together, the grip of the bogies, the efficiency of the lockup converter, the precision of the dual tilt blade, the protection of the slip control, and the intelligence of the data systems, you realize that the Komatsu D475A isn't just a big bulldozer. It's a masterpiece of specialized engineering. It's a machine built to conquer the most brutal places on Earth, and it does it by being just as smart as it is strong. Anyway, thanks for sticking with me for this deep dive into the guts of this machine. It's pretty incredible what's happening under the hood of these mining giants. I'll see you in the next one.